Good morning, everyone. Today, we will see the implementation of decision tree. In the unit 5, already discussed about the decision tree. It is a classification algorithm. So let us see how we are going to implement this decision tree for a particular data set. So for that, here I am using a data set called as diabetes.csv. So for the very first, we know already the pre-processing steps and what to import. The very first thing is we have to import the packages, that is NumPy, Pandas, and for training and testing from sklearn.model underscore selection, we are going to import train test split. And from sklearn.preprocessing, we are importing standard scalar. Because when I observe the data set, there is no proper normalization of the data. So I have used standard scalar for normalization of the data. And here, as we are implementing decision tree, so from sklearn.tree, I am importing the decision tree classifier. And in unit 4, we also discussed about the evaluation of the classification algorithm. So for that, from sklearn.metrics, I have imported confusion matrix, F1 score, and the accuracy score. So let us see the program. The very first step is I'm going to upload the data set. So for that, from this, I'm showing execution in Google Colab. So from google.colab, I'm importing files, and that file I'm uploading. So here, when you click choose file, so from my PC, I'm exporting diabetes.csv, and then I'm reading that CSV file. So you know that I'm I want to print the first 5 rows. For that, I'm using the ds.head, where ds is we have the dataset file, and then I'm printing the length of the dataset. So that is, it is total 768 rows it is having. And then I want to print the information about the whole dataset. So for that, I have used a function called as dataset.information, and this is the information about the dataset, where we have 768 entries, 0 to 767. We have total of 9 columns. In that, these are the features, and last one is the outcome, and there are no null values. And then the next one is just I'm displaying the feature names of that particular data set. So when you see here the data set, these are the feature name. The same thing I'm writing here the feature names. Why? Because I want to extract the all the features, and then I also want to extract the outcome. So that I stored in X variable, and another one I have stored in the Y variable. So so we can in another way we can say that independent variables are stored in X variable, and all dependent the outcome, that is the class label, the target label, I have stored in the Y variable. And this we know that 4 variables have created: training, train, X test, Y train, Y test, and train test split and of this XY. And here I'm giving 30% of the data set for testing, and random state I made it as 0. And next comes our model. Next is building the model. For that, we already imported. From that, I have created an object decision tree classifier with a variable dt. And here the criteria is entropy, random state is 0, and maximum depth of the tree is at 3 levels, and minimum sample leaves equal to 1. So hope you remember, we have discussed when for decision tree there will be information gain and entropy. So here I am using entropy. Actually, default is a Gini, but here I am using the entropy. And then depth of the tree I have given 3, and the minimum samples we required at last I have made it as 1. And then I am fitting this model to the training data of X train and Y train. So next I am predicting the results of test data, and that I am storing in a variable called as Y underscore predict. And this is the testing data. Just I am printing the testing data, and this is the predicted data. Now, to evaluate the machine learning algorithm, the one thing we are going to use is a confusion matrix. This I'm building a confusion matrix of test data and predicted data. Always we will evaluate any model with the test data and predicted data. That only I have given here. I have stored in a CM variable, and I'm printing that. So this is the confusion matrix. Hope you know this is true positive, true negative, false positive, false negative. And this is the F1. Just I'm printing the F1 score. I got some 0.43. And then here I want to show you what is the actual value and predicted value. For that, just I converted this into data frame from pandas, and in actual I'm storing the test data, and in predicted I'm storing the predicted data. And here you can see this is the actual data and this is the predicted data, so that we can find out how many false positives, false negatives our model has given. So for that, just a sample data have represented here. And then the next one is I want to visualize a confusion matrix. Even we have discussed in Navy base and logistic regression also. So for visualizing this confusion matrix from mlx.10.plotting, I am importing plot confusion matrix. And from matplotlib, I'm importing this PLT. And I'm just plotting the confusion matrix. And this confusion matrix is we have stored in a variable called as CM. This here you can see here, this one, the same name I have given here. And the figure size is 6 by 6, and this color is I'm using blues. You can give green also, red. And in X label I want predictions, and the font size I have given 18. And in Y label I want to print actual values and font size 18. And I want to title this particular plotting, that is just confusion matrix, the same font size. And when I want to display that, I have going to use that plt.show. And this is the accuracy score of the test data and predicted data. So this is the confusion matrix. So it's total true positive 145, true negative 24. And this is false negatives, false positives. So total I got accuracy of 73%. And next, from sklearn.metrics, I want to generate the classification report, where I can also generate this precision recall F1 score. So for that, we need to print the classification report. So you can see here the precision and recall F1 score of different class level 0 and 1. So this is general how we are going to implement the decision tree. Here only the new thing here is we have just model we have written for the decision tree code. And here, this you need not to remember, or you need not to execute, but I want to show a decision tree as visualization of decision tree for this particular data set. So for that, what we have to do is from sklearn.tree, how we have imported decision tree, we also import export.graphviz. So it is this particular export the underscore graph is used to export the decision tree. And from that, I'm importing the GraphViz, and I'm also importing the py.plus. And from ipython.display, I'm going to import the image. So these four packages are required to display the decision tree. For visualization of this one, compulsory, we require these four packages. Then here, just I've created a variable, and I'm exporting this one of dt is the decision tree. Output file is none. So feature names, there you can remember here feature names of all independent variables. I have given these names, and the y variable I have given the outcome. The same thing I have given here. Just you can see feature names and the class names. The outcome of this diabetes data set is whether a particular person is having diabetes or no diabetes. Okay, then these are the other attributes required: filled equal to true, rounded equal to true, special characters true. So these are all required for a decision tree graph. And this to create a graph from this data, we use this py.plus.graph underscore from underscore dot underscore data, this dot data where we have created of this one. Now, for displaying the decision tree, simply we use image. Okay, we have imported image to display this there. So image, we are going to create the graph dot create underscore in the form of a PNG. I want to display this decision tree. So the output of this particular is, see here. So when glucose is less than or equal to this much, okay, we got entropy equal to this much, and samples are this one and value is this one, then the class will be no diabetes. So when glucose is this one and entropy is this much and samples is equal to class equal to diabetes. Like this, for each and everything, for each and every decision tree, as we have given the maximum depth of it, tree is 3. So it has given the output as something like this. So you can see no diabetes, diabetes. So when we should no diabetes, diabetes, like that, as per the entropy and or some age factor or samples, okay, BMI. So with the different features, it has given a particular person is having diabetes or not. So in this way, we are going to visualize the decision tree. Before this visualization, the important thing here is to evaluate the machine learning algorithm that we can use with confusion matrix, and we can give a report on classification. Thank you.